Thank you so much, Helen, and the rest of the Puppy and Wins group. We really appreciate everything you did to put together an awesome free event. We don't have a lot of free stuff these days. So we don't have a lot of time together today, so I'm going to just jump right into it. The purpose of my talk today is to talk about the importance of data engineering work streams in conjunction with data science work stream, and tell you guys a little bit about how you can prepare for AI solutions regardless of your organization's maturity for data science. Okay, so as Helen mentioned, I'm an associate consultant here at Salon. I've been really lucky to work on some Gen AI workshops and Gen AI projects. So what we're hearing from the client is that they want really exciting products like conversational AI. They want productivity tools, and they want personalization. Some examples of that is Georgia Tech has an AI TA named Jill Watson. She was born in 2015, and initially she only TA'd for online computer science courses, but she has evolved over the years, and now she can TA in-person and online courses by only being fed a course syllabus, which is pretty exciting. And then I'm going to talk a little bit about go in depth with a personalization use case. And we're going to talk about Spotify's AI DJ. So I am a Spotify listener myself, and Spotify came out in 2023 with a really cool product called AI DJ. And so the idea behind the AI DJ, was to create an AI guide that knows you and your music so well that it can choose what you love. Never has listening felt so personal to each and every user. So it's been kind of a long journey for them, as you can see, from their first acquisition for a music intelligence and data platform to the release of Spotify's AI DJ was around 9 years, but there was probably a lot more planning behind the scenes. So yeah, here's an example of one of playlists that my Spotify DJ made me. It's for today, and it's a happy folk granola vibes Wednesday afternoon. So, you know, they're really getting into the weeds of who I am, I suppose. But unfortunately, not all organizations are at the point where they can implement a product like this. But the good news is that in working with clients, what I found is, yes, they usually come to us and say, hey, I'm looking for a fully fleshed AI solution that's going to make me productive, that's going to make me stand out. But underneath that, what I hear and see clients asking for is the opportunity to participate in AI, to get some skin in the game, to learn by doing, and to evolve with the changing world. And this is something that I believe anybody can start doing regardless of your data science capability or maturity. So that's what we're going to talk a little bit about today, is how you can do this to get you to a point where you can maybe come out with something really cool like Spotify's AI DJ. So let's look back at the story of Spotify and how they got to the AI DJ. So we all see this really cool product here, innovation, but if you peel back the layers, what does that really look like? So like all technology projects, we have time spent and resource management. So when a lot of people think about resource management, they're thinking acquisitions, they're thinking funding, big picture things, right? But something that we kind of forget to think about is data sets. Having data sets that are captured, clean, and relevant. So what does that really mean in the context of an AI solution? Because a lot of organizations do have data sets, right? So just another quote here from an exec at Spotify's Analytics. They're talking about how they process over 1 trillion events a day to inform their machine learning models. And like I said, not all of us are here. Most of us are not here. But the takeaway that I want you to get from this picture here is that underneath all this really cool personalization technology, and underneath these large language models, it boils down to data sets. So we're going to dive into each layer a little more, but the main takeaway from this image I want you to take is that data sets are at the heart of this really impressive, magical technology. So I'm just going to go over each of those layers really quickly so we can get on the same page, and then we can talk about Python, which is why you're all here. So large language models, they are foundation models that are trained on a lot of text. And so some of the popular models that you guys all probably have heard about is GPT and Google's Gemini. And something else I want to emphasize is that what is special about these models is that they are tracking relationships. So it's a little bit of a different way of thinking about data. So we then go into fine-tuning. So this is one of those, so out of the box, out of the box, large language models are very effective, they're really powerful, but they don't give you the value that you might want if you want organization or industry-specific data. And to combat that, we have a few strategies to make changes to pre-existing models. So the first one is fine-tuning, and it's adjusting a pre-trained model to specialize its capabilities. So what this looks like is, at a very high level, adjusting the weights of different tokens. So let's say we ask our large language model, where are some good places to shoot around? Without context, you could either be given an answer about places to do indoor recreational sports, or you could get answers of where to take pictures, senior pictures. So fine-tuning helps your large language model understand what is it exactly that you want to focus on. And then we have retrieval augmented generation, also known as RAG. This is the one that I'm going to dive deeper into today. And what this is enhancing your large language model by adding data from your own internal corpus. And lastly, I talked a little bit about shifting your thinking when you're prepping data for AI solutions. So typically when we prep data sets, we're thinking about reporting, we're thinking about analytics, and that data set is going to be consumed by a human. But when you're working with AI solutions, you're preparing your data set for a machine, and machines interpret data a little bit differently. Machines interpret data as tokens, and they give you an output as tokens. So you're going to shift your thinking a little bit, and you're not going to think about text. You're going to think of tokens. So what are tokens? They're linguistic units, segments of text that are fed into and generated by a machine learning model. So this image here, very high level, but it's kind of tells you what's going on underneath the hood. So these represent relationships, and it will predict based on probability, whatever this algorithm has set up, and determine the next word. So why does that matter? It matters to prep your tokens because these large language models have token limits. So depending on the model, requests can have a limit of up to 128,000 between prompt and completion. So what does that mean? You ask your large language model a question and you get back a response. The question to response, everything from the start to the beginning, will consume tokens. And why does that matter? Well, large language models use something called a context window. And you can think of the context window as how much your large language model can remember at a time. So if you reach your token limit, and let's say you put in a file that says to be or not to be, that is the question, but your context window only grabs the last two lines, you are losing a lot of your semantic meaning. Here's another example of tokens. What I wanted to highlight here is that there is no secret sauce to figuring out how many tokens you're going to derive from any group of characters. That's because tokenization differs for different file types or different languages. So as you can see here, it's the same message with the first hello world in different languages, and they have different token counts. So there are a lot of things to consider when you're prepping your data set. The good news is there are ways to beat token limits, and some of those ways are truncation, which is just to cut down your text, but again, you lose some of that semantic meaning. Chunk processing, which is kind of a newer idea, at least for me as a data engineer, and we're going to dig deeper into that a little bit, but it's basically breaking your text into smaller pieces and letting your model consume those individual pieces rather than a large file. And then you can remove redundant terms. So there's a thing called stop words, and those are words like the, and, he, she. And so you're probably wondering why I'm talking about all of this, why this really matters. And that's because there are a lot of ways to use data engineering to do development with AI solutions. Some of that includes deciding what data to collect, how you prep your data, and governance rules within your organization. But today what I'm going to talk a little bit about is data prep. So I'm going to give you a little bit of a client story, working with a client in the pharmaceutical industry. And what they wanted was an internal-facing conversational AI chatbot to answer industry and organization-specific questions about their IT landscape. And their data that they wanted to inform the chatbot was primarily located in files, so PDF, text, docs, in email threads, so messages, and web pages, HTML. So this is kind of this is not obviously a real image of what they were providing us. So what we actually did was we scraped Confluence pages, but it has proprietary information. So I'm going to use the example of a Wikipedia web page. So this is what you're going to see when you go on theinternet.com. And then this is what it looks like when you pull it out, export it as an HTML file. So not very readable, we're losing a little bit of the images, we're losing the structure, but that's okay. So I put up this arbitrary number of 300,000 tokens. Let's say that we determined that this HTML page had 300,000 tokens. Obviously, that is a very high number. We don't want to work with something that big. Most of these large language models limits are 100,000 or less. So what is the first thing that I would do? At this point, I think it is important to have readability to see what you're working with. So my preference would be to convert it to a text file. At this stage of cleaning your data, I think it's really important to have a full understanding of what you're working with. This will help you later in the process understand how you want to break up those files. This might help you identify some PII in there that you want to get rid of. So this is what I like to do. I like to put it in a way that makes it readable to me. So as we know, Python is the best. We have a ton of open source libraries that we can use. Here are some examples. I personally really like Beautiful Soup. I know HTML parser is getting more and more popular. And then we're going to do just a little bit of data cleaning. So I talked a little bit about how you want to have an understanding of what your data looks like. And one of those reasons could be for security, because you have PII in your data and you want to get rid of it. So here we can see that we're replacing all instances of emails with this X here, and not only does that cut the tokens down, but that also makes sure that whatever you're feeding into the model is secure. Another really cool library, I think it's newer, it's Natural Language Toolkit. They actually have a collection of stop words in multiple languages that you can just pull into your environment and either remove them from your corpus. You can also add to stop words industry-specific words that you deem irrelevant, which is really cool. Okay, so now I cleaned up my data, it's in a text file, I have 50,000 tokens. And it looks pretty good, but I'm still not really happy with this. And the reason why is that there is a lot of information packed in here. I know it's hard to read, but right now I'm looking at 2 different sections. And so what I want to do is I want to chunk this file. I'm going to break it up into 2 files. So we talked a little bit about that earlier, about how chunking is really helpful when you're working with retrieval augmented generation, but I didn't really talk about why. So why chunk? And what is chunking? A reminder, chunking is breaking up pieces of text into smaller manageable pieces called chunks. And each chunk becomes its own unit of information. So looking down at this paragraph, you can see that each different color is its own chunk. It looks like these guys are chunking per characters, but there are a lot of ways to chunk. You can chunk by paragraphs, you can chunk by new lines, you can chunk by headings. It all really depends on, it's kind of a mix of things that determine what is the best way to chunk, and we will talk about how you can measure that. So what is a vector database? Why does this matter? So usually when you're working with data for analytics or reporting, your data is structured and it's in a database that you're very familiar with, but in the case of large language models, your data is sitting in a vector database. So what is a vector database? A vector database is not what you'd expect in terms of tabular rows and columns. And the reason that is because vector databases contain numerical representations of abstract, unstructured things. So looking at this image here, we have a three-dimensional vector, and each of these points is called a vector embedding, and it represents, in this case, a color. So if you guys are familiar with RGB, it lets you know how much red, green, and blue is in a color. So this right here, this green block will be our object, and this will be the vector embedding, the numerical representation, okay? Okay, so again, why are we chunking still? Well, when you go to a large language model and you put in a question to your query, what it does is it changes the input of your query into its own vector representation, right? So let's say I have a Harry Potter book, and I throw that Harry Potter book into my large language model, and these first three dots represent the entire Harry Potter book. And then in my query, I say, I actually don't know that much about Harry Potter, should pick something else. Question about Harry Potter. What it's going to do is it's going to say, okay, you're asking me about Harry Potter, and over at this top, I see that I have a Harry Potter book. So what I'm going to do is I'm going to read the entire book, and I'm going to look for your answer, but I'm consuming all of those tokens. So you might be left with one sentence response. But if I were to break that book into different chapters, and I asked a very specific question about Harry Potter, it might look at this vector representation and say, chapter 1, it's not in there. Chapter 2, okay, we found our answer. So what it does is it gives you more specific answers with semantic meaning, it keeps your costs low, and it keeps things moving faster. Okay, so that's why we chunk. So looking at the wiki example, let's chunk it. I've decided to chunk this file by different sections. So we have the structure section, and we have a high-level nucleotide overview. And this is great, because now we have two different vector embeddings with 25,000 tokens rather than the 50,000 we're working with. That's pretty good. But, there's a reason that these two paragraphs are in the same file. It's because they have a relationship. So how do I make sure that I don't lose that relationship between these two chunks of text? You do something called overlapping. And so what you do is you grab a little bit from the bottom, put them on top, a little bit from the top, put them on the bottom. And yeah, your tokens go up a little bit, so now maybe we're at 27,000, but we still have that relationship between these two chunks of text. And furthermore, it's still better than what we started with, right? So how do you actually chunk? Luckily, there's a really cool library called Chunkify, and it does it for you. So in this example, we are chunking by token count, but you can do it by sentence and new line like I mentioned. And so as you guys can see, there's an overlap of 0.3. That means 30% of the text from the top and bottom will overlap. And you can see that at the last line of chunk 1 and the first line of chunk 2. So they still maintain their relationship. Okay, so anticipate iterative development based on the outputs of your large language model. There's no one-size-fits-all solution for prepping data. As you know, we talked about how there's a lot of different chunking methods, how there's understanding of what your file type is. You have to kind of play with it and measure your outputs. the validity of your outputs or the precision of your outputs. And what does that look like? Oh, actually, I forgot about this. It's pretty cute. Okay, so that looks like a continuous feedback loop. And so it might look like the data engineer modifying your input and the data science evaluating the results of the input, and then rinse and repeat until you get where you want to be. I remember on our last client, we started out with a success rate, I believe, of 65% and got it up to 90. So you just gotta play a little bit with the building blocks. And what are the building blocks? So the building blocks are whatever large language model you choose, whatever vector database you choose, your tokenization strategy, and then some things that we didn't touch on today, which is hyperparameters and base prompts. So again, you can create your own unit test for these, but because Python is the best, there's an open source library called dbeval, which has unit tests that you can adjust for your own specific needs. So here they're measuring what if the input is, what if these shoes don't fit? I think this is for like a retail. And then they measure it against the expected and actual output. So there's a lot of ways to measure the strength of your large language model, but the recommendation is use an evaluation framework so that you really know what you're looking at, and so it's consistent across the board. Okay, and lastly, I talked to you a lot about kind of my specific path for an AI solution. There are a lot of ways to create an AI solution. It's changing by the minute, essentially everything that is happening in the AI world, and so I would recommend signing up for newsletter. I know both of these do daily emails. There's some that do weekly. So just use your resources and learn, get involved. And that is it for me today.
You mentioned the NLTK library for removing stop words from the data set.
Sorry?
You mentioned the NLTK library. I think that's really interesting. Do you find that removing stop words from the input data affects it, causing it to remove stop words from the output data?
Okay, so I don't know if you guys heard that question, but he's basically asking if removing input stop words from your input data will remove the stop words from your output data. And the answer that is very annoying is it depends. So for words like the and they, I think that it doesn't make too much of a difference, but again, you're gonna have to kind of play with it a little bit because it really depends on the subject matter. Anything else?
I have a question about the LLM test case. What is it? Is it like a regression test?
Sorry, could you say that again?
About the LLM test case that you talked about.
I'm so sorry.
The LLM test case.
The LLM?
Yes, like the one you were asking.
Oh, the evaluation framework?
Yeah.
Oh, well, and what's the question?
So what is it like? It's not like regression testing or
No, that's a great question. So he was asking if the LLM framework has regression testing. It actually might. I haven't looked that far into it, but some of the tests I saw were very basic. I'm sure that they have all kinds of things in there, but the ones that I were seeing were like, does it give me back my target token word? Does it have X amount of characters? But I would like to believe that they probably have some of that fancy stuff going on because Deep Eval, it's a really cool program. Something that I also saw was you can sign up for an account and then you can save the results of all the tests you run on your own machine within their cloud, and then you could go back and like revisit it. So something tells me that they have something cooking in that world.
Hi, I have a question about the internet chatbot. How do you get the vector embeddings? How do you get the vector embeddings?
Okay, good question. So she has a question about vector embeddings and how we get vector embeddings. So something that I didn't touch on is that there are vector databases available beautiful out of the box. So some examples of that, I think Pinecone is an independent one. I know AWS has their own flavor. Microsoft has their own flavor. So again, I think it depends on what the secret to their sauce is, but how they derive that numerical representation for each of their objects. Something else I've noticed is we did use AWS for a vector database, and when we ran into problems, we contacted AWS support, and they were like, actually, we don't know what the algorithm is either. So that's another thing that you're going to find a lot is that a lot of these services I feel like are still in beta, and they're a little bit of a black box, but great question. Abby? Hi.
Were you asking about the genetic model? The model, okay. Alright, so what about like each, like, OpenAI has its own two genetic models and so on. So depending on your LLM, you have different genetic models to get those vector relations based on. So, yeah,
Abby has all the answers.
I'm curious, how do you connect the language models to the music? Like, are you using lyrics? Is there other things that language related?
Oh yeah, that's a good question. Let's go back to that. Where's... Okay. I guess the clicker's not working now, but I will show you the slide after, and it's kind of a big combination of things. So they are using OpenAI's large language model. They've also done retrieval augmented generation because they've been collecting their data for all these years now, and that's how they kind of learn about what we like or don't like, just through user activity. And then they also implemented I don't know if you guys are familiar with that OpenAI Scarlett Johansson drama where they were trying to use her voice without her consent. So Spotify AI DJ is actually created a voice based off of an in-house DJ they have for their AI DJ. And so it's kind of a unique combination of a lot of technologies coming together that makes that magic happen.
This whole process you described is probably going to be relevant to a project I'm going to be taking on. Do you have a good resource to look up for the process of tailoring a language set to a model and tokenizing and such? Do you have anything online?
Yeah, okay, so the question was if I have any resources for kind of like fine-tuning RAG and tokenization strategies. So I actually do have a few different websites that I like to use, and I will maybe send out a link to you that you can send out to the group, and it'll include all these libraries that we've used as well as the newsletters, and then kind of some how-to get started guides. So something I really like is deeplearning.ai. They have a lot of free 1-hour trainings, and I think that they're honestly amazing.